Good afternoon, class.
Good afternoon, sir.
I'm also fine, as usual. Today we're going to look at the process we call it as refraction. We're going to look at refraction in lenses. You see, refraction is something very wide, but we are going to be specific on lenses only, because we can see refraction in prisms, can find refraction there. Something very wide, but for us it's very specific in lenses. But before we start our lesson, we need to see what objective we need in this lesson today. What are the objectives, the learning outcome we need in this lesson? In this lesson, one of the major objectives should be knowing how to define what? Lens. Should be knowing how to define what? A lens. After knowing the definition of the lens, then also refraction itself as a process. So we know what it means, what the word refraction means. Okay? And then we're going to look at the applications. So before applications, you need to see the process of refraction in lenses. How this relates process of refraction. Process of refraction in lenses. We're going to draw the ray diagrams. Drawing ray diagrams. Then finally we shall look at types of what? The types of lenses. Are we together? Types of lenses. These are our outcomes we need in this lesson. We know how to define a lens, the definition of refraction itself as a process. Then we shall look at how the process occurs in a lens. Then we draw in the ray diagram. How a lens forms an image, be it virtual or real image. Then we look at the types of lenses, because we have many types. We have two, and are subdivided each of those two. So let us look at the definition of, start from the definition of what? A lens. So what's a lens? So let us start from the definition of a lens. A lens is something which is transparent. Is a transparent object or material. Sometimes you call it glass, which refracts light. Refracts light rays. Like rays falling on it. So as I said, you must know what we mean by lens. Yes.
Sir, what if I get my mirror with its brood, which is somehow big, yes, and it is not painted both sides? Yes. In other words, it can allow light to pass through it. Is it then a lens?
In both sides, or
when no
side
is being painted?
Yes, you can consider that so long as it refracts.
Then
it can refract, then yes, you can consider it, but it depends now on which type of a lens. Because we have different types of lenses. There are those ones which diverge. Now you ask yourself, is your mirror diverging or converging? Or it's doing both. So you have to consider.
It means
We shall reach on it, okay?
okay, sir.
When you look at the types of lenses. Are we together? So now, as we said, you must know a definition or a meaning of what? The lens. Okay?
Yes.
Because the lenses, some of those objects that are in the process of what? Refraction. There are many things which can refract, but we are specific on lenses. Even water itself, any liquid, refract what? The rays of light. Okay? So now we are going to look at, let us look at now the process itself, which is what? Refraction. Okay? Let's look at that. Refraction. So what's refraction? Refraction is just a process. It's simply a process. We look at this process here called refraction. It's a process by which a light ray. Now we need a light ray from a source of light. Process which a light ray. A light ray bends. So when a light falls onto what? Onto a lens, there's that aspect of bending when it goes to the other side of a lens. Assuming this object is my lens, then we make the light ray from the source to fall. So there's that aspect of bending that light ray. That's what we call what? Refraction. It's simply the bending of the light ray when it falls on a lens. Okay? That's what we say, what? That's what we call refraction. Simply the bending. Of light rays. Light rays when it falls. Light ray when it falls. When it falls on a lens. Any type of a lens. Okay. So now we are going to the process of what? Refraction. But before we go there, we need to look at which type of a lens is that the light ray falling. So we're going to look at first of the types of lenses, then we see does this lens converge or does it diverge? The light ray. Before we go to how to draw the ray diagram, how the process of refraction occurs, let us first look at the types of what? The types of lenses before we go there. Because we have different types. There are those ones which converge, there are those ones which diverge. So we can first describe the process of what? Or start drawing the ray diagram. We don't know which type of a lens. See this one. Because different lenses are those ones which converge, there are those ones which what? Diverge. The light rays. So let us look at the types of what? Types of lenses. We have the types of lenses. First one we have here, you see, the converging lens. Some people call it the convex, some people call it the convex lens. So we have the first one called converging lens. So when you look at this first one, it has its what? Its characteristics. When you look at its characteristics, certain type of lens, when a light ray falls on it, it will converge that light ray. Okay? All the light rays will come together after refraction when they fall into what? This converging lens we are seeing, or convex lens. So it has its characteristics. Any question?
Excuse me, sir.
Yes.
What if, again, the light which is coming is converging on the rays, exactly on the rays?
The light which come again?
When the converging point is within the lens, then what can that lens do to that light?
What you need now, you need the parallel light rays to fall into our lens. You don't need again the converging rays to come. You need a parallel one. Because refraction occurs after that the ray passes through that what? That lens. Then it converges from this side. Are we together?
Yes.
Okay. So let us look at the characteristics. Is what? Let us look at the characteristics of this lens here. This type of lens called converging lens. Okay? So when you look at this converging lens, what it does is very thick. Something very thick in the middle. This one is very thick in the middle. Then when you look at this edge, the edge ends, it's very what? Again, thin. We can say small. The what? The edges. So these are the characteristics of what? All the features of the what? A converging lens or a convex lens. It's a lens which is what? Thick in the middle, but thin or small at the edges. Okay? So let us look at the second type of what? Lenses, which is what? We call it diverging what? From opposite of converging. We have diverging lenses. Yes, sir. We have diverging from opposite of converging. So we have the one which diverges the right rays. So diverging lens. Another name we see concave. A concave lens. Concave lenses. So we have a diverging lenses, then a concave or concave lenses. So from opposite of the other, the first one we looked at. This is the second type. So we now look at what happens to this when a light ray falls on this. What does it do? So for this one, it goes opposite to the first one we looked at. So we are going to look at the features or the characteristics of what? A diverging what? Characteristics. We want to look at the characteristics of this what? Of this type of lenses. So what for it goes opposite to the first one we had. So this one here, the first one we said it is thick in the middle. So but now this one here is thin. Thin in the middle. Thin in the middle. Then thick, it goes opposite to the first one we had. Then it's thick at the edges. Okay? Okay? At the edges. Okay? So those are the characteristics of different two types of what? Lenses. So let us look at now how the process of refraction occurs in each lens. In other words, how those ray diagrams move in a lens, each type of a lens. So we are going to start looking at what? Let us start looking at the first one we had, which is what? A converging what? A converging lens. So let us start looking at a converging what? So we have what? We have ray diagram. So the process of what? Refraction. How those rays move in lenses. So ray diagrams. Go look at the ray diagrams. Starting from ray diagrams. So first of all, we shall start from a converging. The first one we had a converging lens. But before we start drawing ray diagrams, do you know the structure of a converging lens? So let us first what? See the structure of a converging lens before we go and draw the ray diagram. How the rays can move in a lens, called a converging lens. So let us first try to draw diagram of what? Called the of a converging what? So we said it's thick in the middle and thin at the what? At the edges. So we are looking at what? The ray diagrams. So first of all, we are starting with our first type of a lens, which is what? A converging lens. So we said, as we said, this lens here is very thick in the middle and very thin the what? At the edges. Okay? So if we assume this this is our middle. Okay? So the ray diagrams, the parallel ray diagrams come. This is our parallel ray diagram. We need the parallel rays. Yeah. So these parallel rays here will be converging. Certain. So we meet at a certain point. Maybe here. So this is where our image now will be formed. But the one passing through the middle exactly. Assuming this our axis. Axis means the axis separating the lens in the middle. These are not a ray diagram, a ray. So our rays are here from the source of light. So these rays will converge from certain point after passing through the what? Through the lens. So when they converge here, the point where they converge, so here the image is what? Image is so this is a general what? General ray diagram. Let us first look at it. When the object is placed at the different positions of the what? Positions of the lens. Let us look at when the object is placed so let us look at when the object is placed beyond what? Beyond F. When you say F, is no focus. As you look at the reflection, the mirrors, F is a principal focus. So we can have our lens. You can draw it like this. You can represent it like this. My axis, principal axis, as you look at the reflection. So, if this is my F. So object is placed beyond what? Beyond F. As we say, object is placed beyond F. So we shall see a ray coming from our object. This is our object O. So it will come the lens, but it's converging after what? Refraction. So it will be falling like this. Then another one will come, passing through the what? Optical center. Optical center, as you saw in the reflection, is the center of the what? Center of the lens. So this one will also come. So let us try to draw. This is our first ray. This one will be converged. It will be converged to pass through what? The principal focus on the other side, the lens. So it will come like that. Then another ray comes, passes through the optical center. But the ray passes through the optical center is not refracted. It goes straight to meet the other one, passes through the principal focus. And where the point where they meet is where the image is formed. So we shall see it will come through the optical what? Optical center. So where they meet, the one passing through the ray passing through the what? Where they meet, the ray passing through the F principal focus. The other side of this lens, so they meet at this point. So the image will be formed where? At this point. So we need to look at the nature of the what? Image formed. Because those ones who have graphs can use graphs. And it's very perfect when you're using a graph. Graph makes it clear. And the measurements can also easily be taken when you're using a graph, and make sure that you're using a ruler. You must need a ray, straight line with an arrow showing where the ray goes. Okay? So this will be our image. Okay? So when you're using a graph, you can easily see the properties of the what? Properties of the image form. You compare the image the size of the image and the size of the what? Size of the image and the size of the object. So compare their sizes. When you're using a graph, it's easy to what? To depict, and you can take measurements. And then again you can say the position where the what? The position where the image is formed from the wire, from the lens. Then you can say the nature of the type of image formed. Is it a real image, or is the what? Or is the virtual image, or a rect? Okay? And then you can also measure the distance from O, optical center, to the image point. You can easily measure that distance when you're using a graph and a ruler. So you can easily describe the nature of the what? You can easily describe the nature of the what? Of the image formed. Okay? By simply seeing what's formed there. When you're using your graph. Are we together? Okay, that's very good. So now let us look at, for example, like this one I have shown here. Assuming this is my graph. This is my graph, and my lines are straight. All the rays are very straight. They're using the ruler. So we see these are objects placed beyond what? Beyond F. Beyond the principal focus. Okay? So we look at here. Our image is formed here. So when you look at this image, actually this is a real one, a graph. The image size. So when you look at the features, of the image formed. Let us analyze the features one by one. The size of the image formed is bigger than what? It's bigger than object size. Image size bigger than what? It's bigger than object size. As you can see from there, image size is bigger than object size. Next one we have here, let us see in which what's the distance from the image to optical center. So you can easily measure using what? Using your ruler. Then you write that property. Also, we shall look at the type of the image. Is it the real one? Is it the what? Virtual one. So when you look at this one here, this image is real. Okay? It's not what? Virtual. The virtual image are replacing with what? With lines. But when you see a full line like this one is a real what? So you write that one also. A real what? Image. Okay? When you look at it, how it is standing, is it inverted or not inverted? So
Excuse me, sir.
Yes.
What do you mean by being inverted or inverted?
Inverted, look at the arrow where the object was facing.
Yes.
Okay? So when you see this one, the image from here, it's also standing there. It's pointing the same point where the what object, the same direction where the object was pointing. Then that one means it's not what? Inverted. And now we see, let us see our object is inverted. It's facing upward, but our image is like this one here. It's facing back, downwards, okay? Then what we do to represent our image is facing downwards. So it's contracting the what? The object. Okay?
Okay, sir.
So we call this one to be what? Inverted what?
So what if I call it the image is upside down?
Or how that one goes the other one. You can say inverted or in bracket upside what? Upside. That's very good. Same. It's got the same meaning, okay?
Okay, sir.
So that is. So let us see when the object is now placed what? When the object is placed at what? When the object. Another second slide, another second part. This one, the first one was when the object was placed beyond what? Beyond F. Now the second part when the object is placed at something like 2F. Okay? So let us look at when the object is placed at what? At 2F. When the object is placed at what? 2F. 2F means you're doubling F. One F, then another F. Okay? So we shall sketch the normal way, but the position of our object must be at 2F exactly. So we shall be sketching it like this. assuming this our what? This our converging lens. Okay? So when you look at this one here, if this is my F, so 2F means you're doubling F. So if this is F, 2F something like this distance here must be the same as this one to make it 2 what? 2F. So that's my 2F. Then this optical center. In this case also 2F. Now when our object now is placed at what? At 2F. Okay? So we shall achieve this our object facing upwards. Okay? So the first principle we say the ray. A ray comes right passes through the what? A ray parallel to the principal axis. This is our principal axis. This what? Converge. It passes through what? Through the principal focus. Then the one which comes direct through the optical center goes unrefracted. So where they meet, the two rays meet, so where our image is from. So you draw your image there. You draw image there, then you start analyzing the features of the what? Image from. So it's something very simple. Okay? So you analyze the features of the image or the characteristics of the what? Of the image from. Okay? So we are going to look at, maybe we look at when the object is placed at F exactly as the principal focus, the last part of this converging lens ray diagram. When the object is placed at what? F exactly, what do we mean from? So let us see when the object, you can say object is what? At the F exactly. So we shall see this. Our lens also has to be in a graph. So if this is my F, this is my F. Okay. We are now looking at when object is at what? At F, at our principal focus. So try to draw an object in our principal what? At our principal focus. So we have a ray that's parallel to the what? Principal axis. Is our principal what? Principal axis. So we say the ray parallel to the principal axis must pass through what? The L. So it will go like that. Okay? Then we have what? The one passing through the optical center is not what? Refracted. So when you look at this one here, it says for this one now, look at this one very well. You have not seen any intersection of the light rays. So what you say this one the object from that what? At infinity. It's not long, very far distance. Where you see this very lines. I don't know, maybe the rays will intersect from somewhere. So it means from that infinity. There's no intersection we have seen there. So the image will be from that what? At infinity. So when I ask you the features of the image from features or characteristics, how the image looks like. Okay? So we say it's formed at what? At infinity. Image is at what? Is at the infinity. Infinity means the very far distance, which we can locate from here. So this is what the ray diagram what? When the object is placed at what? At the F exactly. When using a converging what? When using a converging lens. Okay, we're going to look at the last part of this ray diagram in a converging lens. And the last part is when the object is placed at what? The ray diagram when the object is placed at it, or in between optical center and then principal focus. In between F and O. So let us look at object at the O in between F and O principal focus. F and object in between F and the optical center. Optical center is the last part in the radar ground. We're combining what? We're combining lens. So let us look at, we apply the same principles. So we have what? So you're still looking at our last radar ground combining lens. We say when the object is in between F and optical center, that will be this point here. So this is our object. So we're going to, as usual, our rules of drawing the rays remain. So we ray parallel to the principal axis. We refract them. So do the what? Do the principal focus. Then, as we said, the ray passes through the optical center. Optical center is not what? So we are going to extrapolate these rays. We are going to extrapolate what? We are going to extrapolate these rays here. We shall form a certain type of image. Extrapolate using a ruler. Those are using a graph. It must be a perfect one. So the image form we shall form here will be sort of a virtual image and must not be inverted. That one. So the image, as you see, the image form is some image which is very big. It's bigger than object. So it's formed on the same side as the what? As the object. So let us look at the features of the characteristics of the image formed when the object is placed in between F and the optical center. Okay? So as we see, the image will be forming big. So image is big or magnified. Image is bigger. Another one bigger, you can say magnified. So image from here is certain image which is very big, or you can say it's magnified. Then also the image is formed at the same side as that of object. So image formed the same side as same side as the object. So we can say our image is what? Vertical. Image, you see? Vertical. So you can use the right. Use all those features of the characteristics from your radar diagram. You have to make sure that you have drawn a very good radar diagram which is correct. Then other features will come. The features of the image will come from the radar diagram. So allow me this time we go to look at the radar diagrams in a converging lens. Let us go into what? I mean a diverging here. Then the converging lens, radar diagram in a converging. Let us look at the diverging what? A diverging lens. So let us look at the radar diagrams in a diverging or a concave lens, diverging lens. as we said first, the features of something is diverging, and then it is diverging, so it is thin in the middle, then it's thick at the edges. So when you look at, try to sketch it, you say this one is what? Diverge the rays. Diverge what? The rays. So when you look at this lens here, these are principal axis, meaning the way when you indicate here, sort of, you have to indicate the image of what? Something that reflects as if it's what? A diverging lens. So this is our diverging lens. So when you put objects, this point here, any point you put your object, for this case, this is understand the matter. This is my F. So we say the ray, these are diverging the rays. So a ray that will be parallel to the principal axis will be diverged. So it will be diverged like that. So when you extrapolate that diverging ray, it will be passing through the what? Principal focus. Then the ray passes through the optical center, goes straight and diffracted. So where are those two? The one which was extrapolated and the ray passing through the optical center straight, where they need to be our point, where the image is forming. So this is our image. So when you look at the features now of the image forming, features of the image form. So this one does not mind. Whenever you put your object, the features will be the same. The image will be small. As you see here, this is our object, this is our image. Image is small or diminished. Now what means small. And then it's a virtual image. So when we look at plus other features, those are which you using a graph can get the measurement, then you say measure the distance of the image from the what? Equal center, then you measure another one as one of the features of the characteristics. So for that case, allow me to review what we have learned today. As we say, our objectives for this lesson. So you looked at what? Definition of what? You looked at the definition of a lens. You must know the definition of a lens, what a lens means. Then you looked at the definition of what? Diffraction. A refractive, we looked at types of lenses. Where we say there are two types of lenses, converging lens. We say the converging lens and what? A diverging lens. So another name we say for converging lens, we say this also called what? A convex lens. Then for a diverging lens, we say this also called what? A concave lens. Okay? Then we look at the features, so the characteristics of a converging lens. So look at the features, we say a converging lens or a convex lens is thick in the what? It's thick in the middle and it's thin it's thin at the edges. Okay? Then you look at the features of the diverging lens, we say this one is the opposite of the other one. It's thin in the middle and it's thick at the what? The edges. Then we went on, looked at the ray diagram for all these types of lenses, and we started with a converging what? A converging lens. Okay? Where you said you can look at different points. Object can be placed where? At the different points of the principal axis of a converging lens. So we looked at when the object is placed at it, maybe beyond F, then at the F, then in the middle of what? F an optical what? Optical center of the lens. So then we looked at the diagram for what? For a diverging. The red diagram for a diverging lens, where we say this one does not mark the position of the what? Object. But what will be formed there? Will form something which is what? Which is virtual and it's very small or diminished image. So allow me this time say that next time I will give you the scenario and the revision questions that will try to summarize all the things, what we call the refraction in the lenses. So next time we shall look at application of what? Applications of what? Refraction. Why I apply this knowledge of what? Refraction in daily life. So next time we shall look at this over here. So thank you for attending. Wish you the best of your day.